Now, another really interesting electrical device that you should probably understand how it works is called a transformer. A transformer works using electrical magnetic induction by, if you have a current flowing through this coil here, which acts like a little solenoid, the magnetic field lines go through this magnetic material, which could be iron, for example, or steel, and go in a loop. The magnetic field lines are mostly inside this, inside the ferromagnetic material here. So run a current through there that creates a magnetic field. The magnetic field goes through here and then creates a current on the output side. Well, we can sort of demonstrate that by this device. Here we have a coil, a solenoid, wrapped around what's actually a steel rod here. We just keep it covered by this plastic for reasons that you'll see in a little bit. Now, when I energize this, what happens? It's connected to the wall. The wall has 120 volts oscillating at 60 hertz, right? And that is put across this coil here. So you have alternating current, 60 hertz, going back and forth and back and forth. That means the magnetic field is up and down and up and down and up and down 60 times a second here. So I'm going to put this loop of wire that has a light bulb attached to it, just surround that iron core. And when I turn it on, the light bulb goes on. There's no battery or anything here, right? And you can see that even way up here, well, as you get closer and closer, the magnetic field is dropping off as you get away from the coil down there, but it's quite strong. So it's oscillating. We get an oscillating current inside this coil due to the changing magnetic field here. Now, that's acting like a little transformer. The math works out like this. You remember from Physics 7b that the power, if you have current times voltage, that's the power. So there's some power in here, which is the current times the voltage across these two things. Now, the voltage is alternating current. The same formula that we had in 7b works for alternating current just as well as it does for DC current. Now, transformers are very efficient, meaning that the power out that you get out of the transformer is basically the same as the power in. Well, now we know that, so we call this the primary side, and we call this the secondary side. The primary current times the primary voltage, then, is equal to the secondary current times the secondary voltage. So IP VP equals IS VS. Well, we can decompose that into the ratio of the primary current to the secondary current is equal to the ratio of the secondary voltage to the primary voltage. Now, it also turns out that that's related to the number of turns in the secondary divided by the number of turns in the primary. So if you have different number of turns, and this one has maybe 2 or 3 times as many turns on the primary as the secondary, what does that mean? Number of secondary turns is less than the number of primary. That means the secondary voltage is smaller than the primary voltage, and the primary current is less than the secondary current. So this would be a transformer which gives you smaller voltage on the output, but bigger current. And you can do it exactly the opposite as well. So that's how alternating current transformers work. And you'll find these are ubiquitous these days, right? I mean, to charge your cell phone, you plug this thing in the wall. The wall has 120 volts. If you put 120 volts across your cell phone, it's going to zap it out, right? It only wants maybe 12 volts at most. So you're taking that alternating current and stepping it down. The first thing that you do is step it down to lower voltage, and then there's a circuit to rectify it and smooth it out and make it into a charger for your cell phone. So let's do a clicker question about this. Suppose you have a transformer, and here's the equation governing them. And it has 100 turns on the primary side and 1,000 turns on the secondary side. If you have a primary AC voltage of 120 volts, what's the voltage on the secondary, the output side? Just using this formula. Should be straightforward. Should be able to do it in your head.